Hello. Today we're going to be using our physical representation of a PIC18 microcomputer to run a simulation of a program that's going to turn port A into S, U, P, and write the word SUP. So we're going to run our first instruction right here, which is going to clear tris A. But before we do that, we got to increment our program counter to 2. So you see I just flipped a bit, made that 2, and that means we cleared tris A. So FF turns into a 0, 0. Now for our next instruction, we're going to clear tris B, which means this right here is going to get flipped over, and our program counter is going to get put to 4. And tris B is going to be cleared from FF to 0, 0. Now we're going to run our next instruction, and we're going to clear tris C. So as you could guess, now our program counter is going to go to 6 because it goes increments by 2 every time. And we're going to clear tris C, set that to 0. Our next step, we're going to write the source of our program memory at address 22 hex, where we hold the letter S, represented by 6D, U, which is 3E, and P, which is 73. So our source and program memory, where our word is stored, our letters for the word, we're going to load that into the write register, which is 22. Move LW 22. First, we got to increase the program counter by 2. Now we flip those bits. We have 8 over here. And in our write register, we're going to have 22, which is represented by flipping a bit in the 2's column and flipping a bit over here. 22. Next step, we're going to be doing a move. We're going to first increase this to A, which is 10, the program counter. Write register stays the same, but we moved our source, our program memory 22, to table pointer low. So this gets put into 22 as we move what's in the write register from here to over here in table pointer low. Next step, we're going to point at what's actually located at this address, which is going to be our S value. And so we're going to move whatever is the value here to tablet. But before we do that, we're going to increase the program counter so we don't forget about that. That goes from A to C because it increases by 2 every time. Now that we've done that, let's take tablet and let's put 60 in that spot there. All right, time to move on to our next step. I'm going to increase our program counter again from C to E. Now, what we're going to do is we're going to move the value in tablat to our W register, so we can write it to the port next. So our W register goes from 22 to what's the value in tablat, which is 6D. And 6D represented in binary, it's going to be 1 here, 1 here, 1 here, 1 here, and a 1 here. And there you can see that this is going to be equal to 6D. Table pointer stays the same, tablet stays there. And now next step, we're going to move on. I'm going to go down to move port A. So we're going to move value 6D. First, we're going to increase the program counter to 10. Hex 10. W-reg stays the same. And we're going to be putting in port A 6D, which is also going to move right here. Port A. I'm going to turn on the light. Let's draw that in so you can see it. And there you see we got our S. Next step, we're going to increment the table pointer. Let's first increment the program counter before we forget to do that. Now it goes from 10 to 12. And now we're going to take the table pointer, make that 23. Next step, we're going to point to the value of this address. Let's increase this here. 14. Program counter always increases every instruction. Now we're going to move tablat. That's what we're going to point tablat to the value that's at this address. The value that's at this address happens to be 3E, which represents a U on the LED display. All right, next instruction. Going to move tablat to the right register. So we're going to increase this 16. And we're going to move 3E to the W register. Three E has 0, 1, 1, 1, 1, 1, 0, 0. Now I get 3E in the W register. Now we can move that to port B. Now we're on step 18. Put a program counter, 18. And now we move the value in the W register to port B. Now I get 3E and port B, which is able to turn on this light. Port B. There you can see it says SU. Next step. Increment table pointer. Let's first increment the program counter before we forget to do that. Alright, step 1A. Step 1A. And this goes to 24. All right, next step. We're going to point tablet to whatever value is stored at this address. But first, let's increase our pointer, our program counter, from 1A to 1C. Now that we're at 1C, we can finally make our tablet point to value at 24, which just happens to be 73 in program memory. 73 representing the P in SUP. Now we can move the value in tablet to our write register. First, let's increase the program counter from 1C to 1E. Now we've got 1E in the program counter. And we're going to be moving 73 to here. W register. Copying what's in tablet to here. Three. This is 1 1 0 0 1 1 1 0. All right, now we got our value 73 in there, and our program counter increased. Our next step, we're going to be completing our word by moving the program counter to 20. You can see our program counter moved to 20. Value 73 move from W register to port C, which from port C turns on value 73 hex, which gives you and then it sleeps. The program turns off. Sup. Here we go. Hope you had a good time watching.